Hello, welcome to our channel for rprogramming. In this video, we will talk about cross-validation application in regression using R. So we know in regression analysis, if you obtain the parameters, so these parameters in the model will maximize the R squared. This is a coefficient of determination, or say maximize capturing the variance of observations from our estimated model. But this only applies to the set of sample data. So if you use this model to a new sample of observations, this may not necessarily perform as well as the model performs on the sample data used for estimation. But how much is the gap of these two kinds of model application? So one kind of method is called cross-validation. So cross-validation used for evaluating the generalizability of a regression equation. And of course, cross-validation can also be used in other statistical or machine learning application. So in the regression, if we select a sample data, so usually we can set a portion of the data for the training sample or in the model estimation. But the rest of the data we can set aside as the holdout sample. So this part of the data is not used in model estimation. Then we use the training sample in regression analysis. Then we get the model and then try this model on the holdout sample. So this kind of method can make you to be clear what's kind of the performance on the data that have not been used, have not been seen in model estimation. And in cross-validation, one often used approach is called k-fold cross-validation. So this means to dividing the samples, all the data in the samples into k subsamples. Then we use one of this subsample as the holdout sample, and we use the rest of the k-1 subsamples as the training sample. So after we perform k prediction equations, because such kind of portion of data can be used k times, because each k sample can be different for the holdout. So the rest of the k-1 subsamples can also be different. So we do k times prediction or k times training or estimation of the regression model, then do k times holdout samples usage from the estimated model. Then we get k results from holdout samples estimations results. Then we can average this one, then get the result of how it is performed of the model on the unseen samples. So note that if the k equals n, so which means we set n subsamples in total. So we test n times of the model and have n times different holdout sample. So this means holdout samples sample size is only 1. So this kind of k-fold cross-validation is called jackknifing. So next we will show how to implement this in RStudio for cross-validation or k-fold cross-validation. So there's a function called shrinkage user-written function, and input is the estimation model for the linear regression model. Then k is, for example, we can set 20 or 10, but usually it's 10. Can set a seed one. So in the function, we require a library called bootstrap. You have to install this first. Then there are two functions. One is fit, theta fit. So this actually gets information from the model estimation. Then another function is theta predict, which is used to calculate the results after we have estimated the model. Then x and y is the independent variable matrix and y is the dependent variable. Then we set a seed, and next is the main function called crossval function from bootstrap. So crossval x and y, then two objects fit from the model estimation and predict function. Then crossval function will do operations for the cross-validation for you. And here the K is for K subgroups of the sample. So after this is done, we can calculate two coefficients of determination. The first is R2 is actually from the fitted model, then correlation between y and the fitted y value, then take a square. So this is the R2 from the model which have used the samples in the estimation. So this is usually is higher one, is a very good one. Then is the cross-validation R square. So this is from the result, which is the cross-validation function running. So next we show these two numbers. So we create this function first. Then we use a data frame called states. Actually, it is created from a matrix, and we select 5 different variables. Then from this data frame, we estimate a model using linear regression, then assign the result to the fit. So here dependent variable is murder, and other 4 variables used for independent variables for this data frame states. So the model is estimated, and we can use this function, shrinkage function, to perform the k-folds. So the result is original R squared is 0.56, but the cross-validation R squared is only 0.35. So it is quite lower. So this is why we call this function shrinkage. It's shrinkage for the R squared. They're only 35%. But if we change the model, we only add 2 variables in the independent variable. Then we estimate again and input these results, fit 2 in the shrinkage, we will see. So now this 2 is quite close because we removed 2 independent variables in the model. So cross-validation helps you to evaluate the model structure. But of course, this is not what you can decide only from cross-validation, but this is help you to evaluate. Of course, the model determination establishing is based on many factors, mainly from the previous research or the theoretical approach, and so on. Thanks for watching.